are present in the flow stream, various flow regimes may result. If the flow is water and oil, a bubble flow regime is most common. When gas and liquid are present, the flow is much more complex. Bubble flow probably exists up to a condition of about 10% gas by volume. A transition then quickly occurs to slug or more complex flow patterns. Unlike oil-water flow, gas-liquid flow is very turbulent and violent and produces a very complex response in the flow meter. As a result, gas-liquid flows can be difficult to measure accurately. The two terms used in vertical flow measurement, hold-up and cut, are often misunderstood. Cut refers to the amount of a particular phase that is being produced. For example, if 1,000 barrels per day, 159 cubic meters per day, of liquid is produced, and 350 barrels of it are water, the result is a 35% water cut and a 65% oil cut. Hold-up, on the other hand, refers to the fraction of the wellbore bulk volume occupied by one of the phases. For example, if we have a standing water column in the well with oil above, and we flow oil into the wellbore, the oil will bubble up through the water and flow out the top. We would have a 100% oil cut at the surface, but across the bubbly interval, the oil bubbles might occupy only 30% of the volume, and that interval would have an oil holdup of 30% and a water holdup of 70%. Because of the density difference, water is likely to accumulate downhole in all wells, even when the water cut is small. The difference between the cut and holdup can be dramatic, especially at low rates. At 300 barrels per day, 48 cubic meters per day, a 1% water cut at the surface may mean a 50% water holdup downhole. Measurement of phase holdup is done using a gradiometer, which measures the bulk density of the fluid over a 2-foot interval. This is done by measuring the pressure difference over that interval with a mechanical or electrical gauge, or by using a nuclear device which relates the rate of gamma ray penetration through a fluid to its density.